week 3. Okay, so it's purely the doubt clearing session. So I'll ask you guys that if you have any doubts, then we will solve them here. Okay. So the thing is, we are not doing the summary session in this particular term because this term is divided into two parts. So we won't do summary sessions. You can go and check the videos. There are also one link is provided to you in which we have collected all the best possible live videos so far we have done. Okay, so you can just go and have a look at those live videos and you can find any topics in those live. Okay, so I hope you have gone through. If you haven't, then also you can let me know. We can consider one more session if you guys want, and we can discuss the doubts there too. Okay, so I'll start with the doubts. So if you guys have any doubts, you can either raise your hand or you can post your doubt in the chat box. Okay. So, but before going through the doubts, let's quickly recap what are the things we have learned in week 3. Okay. So, week 3 is actually based on quadratic equations and parabolas. So, I hope I'm audible. I'm audible to everyone, right? Can someone give me the confirmation?
Yes.
Anyone? Yes. Okay. Cool. So let's start with the quick recap. So it's just the basic knowledge. You already know what are the quadratic equations and all those things. So what is a quadratic function? Okay. So a quadratic function is nothing but a function in which we have a x square type of term. Okay. So the general form or the standard form, as for equation of line also we have a standard form. Y is equals to mx plus c. Similarly, we have a standard form here too. So it says that if you have a function q of x like this, ax square plus bx plus c, where we are assigning some condition over abc. What are these abc? So abc are actually real numbers in such a way that a is not equals to 0. Because if a will be 0, then this x square term will vanish and it is no longer a quadratic function. Okay. So here any quadratic function will have this particular form, ax square plus bx plus c. Okay, so this is the general standard form. Now, the second question we can ask is that which figure this particular quadratic function will demonstrate. So, for example, if you plot this figure into Desmos or some graphing calculator, which type of figure you will get? So, the answer is we will get a parabola. Right. So, you know that there are two kinds of parabolas which represents the functions, right? One is an upward parabola, another one is a downward parabola. So, that means any quadratic function will represent an upward parabola or a downward parabola. Okay. And the location of parabola will be determined by its vertex and axis of symmetry. Okay, so I'll explain what is a vertex for a parabola. This is all just basic knowledge you guys already remember, but it's good to recall. Okay. So what is a vertex for a parabola or what is an axis of symmetry for a parabola? So first of all, we will understand what is an axis of symmetry. Okay. So for any parabola, we know that a parabola will have a two wings. Okay, one is this and another one is this. So what is an axis of symmetry? So axis of symmetry is that line on which if you place a mirror, then these two wings will be the mirror image of each other. For example, in this parabola, roughly speaking, if you place any mirror over this particular green line, then what happens? These two wings will be mirror image of itself. So that means you can find that though these two sides are nothing but identical to each other with respect to this particular line. Okay. So such a line is known to be axis of symmetry. Right, as the name suggests, axis of symmetry, that means about this axis, both the wings of parabolas are symmetric to each other. Okay. Now what is a vertex? So vertex is actually that point where the axis of symmetry and parabola intersect each other. So that point on parabola is known to be the vertex of parabola. So this point is known to be vertex. Okay. So what is an axis of symmetry? Axis of symmetry is that line about which both the wings of the parabola are symmetric to each other. And what is a vertex? Vertex is actually that point where the axis of symmetry intersect the parabola. Okay. Now, the thing is, if we have a general equation of parabola, that is q of x is equals to ax square plus bx plus c, then we have an explicit formula for finding what is our vertex and what is the equation of axis of symmetry. because again, excess of symmetry is just a straight line, and for any straight line, we can have an equation. Okay. So here, one thing about excess of symmetry, we can notice that it is nothing but a which line? It is a horizontal line or a vertical line? It is a vertical line because it's parallel to y-axis, right? And for any vertical line, the equation of that line is nothing but the given by its x-intercept. Okay. So here, the equation of axis of symmetry and the x-intercept of the vertex both are actually same, because we are considering vertex to be the intersection point of axis of symmetry and parabola. So we can say that the equation of axis of symmetry is nothing but x is equals to minus b by 2a. And since the vertex is a point, so for any point we have two coordinates, x coordinate and y coordinate. So x coordinate of vertex is same as the value of x intercept of axis of symmetry. So that means, and the coordinates of vertex are nothing but minus b by 2a and the q of minus b by 2a. Right? That means you will substitute minus b by 2 in place of x. So whatever value of y you will get, that is your y coordinate of the vertex. Okay. So these are the two basic facts about parabolas. If one is the axis of symmetry. So equation of axis of symmetry is given by x is equals to minus b by 2a. Another one is the coordinate of vertex. Okay. Now here one more thing is there, that how can we judge by a equation? So suppose a quadratic equation is given to you, and if you want to judge it's an upward parabola or downward parabola just by looking at the equation. Okay, so that thing will be determined by this particular A. So whatever sign of A is there, that will guarantee us, that will tell us that which type of parabola do we have. Okay, so that means if you have q of x is equals to ax square plus bx plus c, and if A is a positive number, any positive number, then this expression will represent an upward parabola, right? So this will be an upward parabola. And similarly, if A is less than 0, then this will be an downward parabola. And we know that A can't be equal to 0 because A is the coefficient of x squared. Okay. So these are the very small things, but it's you should always keep in mind that by looking at the expression only, you can tell it's an upward parabola or downward parabola. Okay. Now, another fact about quadratic equations are their roots. Okay. So first of all, what are the roots or zeros of any function? Roots, zeros, or x-intercepts. These all things are same. Okay. They have given the different range. So the ultimate meaning is we need to find out those values of x where the function value is becoming 0. Right. So for a parabola, so for a q of x, the roots are those values of x for which this q of x is becoming 0. Okay. So that means ultimately we need to find those values of x for which q of x is vanishing, right? Or cutting x-axis or intersecting x-axis. Now, the thing is, for quadratic equation, we have a closed form, which is also known as Sridharacharya formula. So it says that if q of x is given by x square plus bx plus c, then the roots are, or zeros or x-intercepts are, given by the formula x is equals to, can someone tell me what is the formula here? Are you guys awake or want to sleep? Okay, so
B
it's
minus root of B square, no, 2A. Yeah, sorry.
4ac by 2a. Is that correct?
Yes, ma'am.
Yeah. Okay. So this is the closed formula for finding the roots of any quadratic equation. Okay. So in this formula, let's observe something. So here you guys know that this under the root function is something which is a reason of getting a complex number, right? Because we know that we cannot find a real number whose uh, no, we cannot find this particular thing as a real number, right? So under the root of -1 is not a real number, because we know that any number square will become positive, so that's why under the root of -1 doesn't make any sense. Okay, so this under the root is something which is the reason of a complex number. Okay, sorry. So here in under the root, which quantity we have? So in under the root we have this b square minus 4ac. So actually, this b square minus 4ac will help us to determine the nature of the position of roots of any parabola. Okay, so that's why this is also known as the discriminant of parabola. Okay, and based on b square minus 4ac, or based on the value of b square minus 4ac, we can tell that our given quadratic equation will have a real root, will have a same real root or distinct real root, or complex roots or imaginary roots. Okay, so let's state those cases. So we know that if the value of b square minus 4ac is less than 0, then what can we say? We can say that under the root of b square minus 4ac is a complex number, right? So that means whatever value of x here we'll get a complex roots, right? It's also known as imaginary roots. Okay, so now what will be the second case? Second case will be when the value of b square minus 4ac will become 0. Okay, so here in the formula you can observe that in place of b square minus 4ac, if you substitute 0, you will get only one value of x, which is minus b by 2a. Okay, so if b square minus 4ac will become 0, then we can say that we have only one root, or same root also, same real roots also, they will say. And what is that root? That root is x is equals to minus b by 2a. Okay, so is there anything special about this x is equals to minus b by 2a? Can you say what will be that root if b square minus 4ac is equals to 0?
There's only one root, which means the vertex is on the x-axis.
Correct, correct. So this is nothing but the x coordinate of a vertex, right? So that means vertex is the only root of that particular parabola. So that means in this scenario, your parabola will look like this. If it's an upward parabola, something like that, it could be anywhere over the y-axis. If a downward parabola, it will be like this. So that means it will touch the x-axis at a single point. It won't intersect the x-axis. Okay, similarly, in the first case also, when b square minus 4ac is less than 0, so here we are getting an imaginary root. So that means your parabola will float. It won't intersect the x-axis at all. It will be, if it's an upward parabola, will something like this, or downward parabola, something like this. That means it won't intersect the x-axis at all if b square minus 4ac is less than 0. Okay, now let's go to the third case, which says that if b square minus 4ac is strictly greater than 0. So in this case, we will have two roots. One root will be minus b plus under the root of b square minus 4ac, because now it's a real number, right? It's a real number and not equal to 0, obviously. And another root is x is equals to minus b minus under the root of b square minus 4ac by 2. And we can immediately say that these two roots will be not, different, distinct. So when the value of discriminant is strictly greater than 0, or the value of b square minus 4ac is strictly greater than 0, the parabola will have two distinct roots. And that means your parabola will intersect the x-axis exactly at 2 points. If it's an upward parabola, or if it's an downward parabola, something like this will happen. Okay, so these are the cases about roots of parabola, roots of any quadratic equation. Okay, now there is another thing that there are several methods to find the roots of parabola. One is creating a perfect square method, prime factorization method. All those methods are, I hope, familiar to you, but let's recall. So one is known to be the prime factorization method. Okay, so in that method, what you will do? So suppose you have q of x is equals to ax square plus bx plus c. Okay, so then you will find two numbers. So suppose alpha and beta are two numbers, two real numbers. You will find two real numbers in such a way that their summation will become, alpha plus beta will become b, this b, and their product will become a into c. Okay, so yeah, someone may recall these methods in place of a, if you have one, then it's only c. But suppose if we have a and c, then ultimately we need to find two numbers such a way their product will become AC and their summation will become B. Okay. Yeah. So this is known to be the prime factorization method. One example we can do. So suppose we have a q of x is equals to x square plus 9x plus 14. Okay. So now here, can you guys tell me what are the values of alpha and beta we should choose? We want summation to be 9 and product to be 14.
7 and 2, 7x.
Correct. Right. So what we will do, we know that if you choose alpha 7 and beta 2, then their product will become 14 and summation will become 9. So what we will do, we will distribute this middle term into these two parts. So that is x square plus 7x plus 2x plus 14. And then we can take common x here, we'll get x plus 7. We'll take 2 common, x plus 7, and ultimately we have two factors, x plus 7, x plus 2. And then we can equate them 0. So we'll get x is equals to minus 7 and x is equals to minus 2. Okay. So this is known to be the factorization method, which is very standard for finding the roots of quadratic equations. Okay. Now there is another method which says that completing the square formula. Okay. So what does it says? It says that if you have a quadratic equation, then you need to you need to add a constant in such a way that will complete the square of this particular equation. For example, let's see. Suppose I have this q of x. So q of x is equal to x square plus 4x what's that plus 5. Okay, so let's take plus 5. So suppose this q of x you have, and someone asks you, can you find out the roots of q of x is equals to 0 by completing the square method or not? Okay, so in that case, what you need to do, in this particular equation, x square plus 4x plus 5 is equals to 0. Yeah,
Ma'am,
yeah,
we'll
correct.
add 2 ka square and we'll subtract 2 square.
Correct. So that means because here 4 is there, so we know that 4 can be written as 2 into 2. So we need 2 square here. So we already have 5, right? So we can distribute this 5 into 4 plus 1. That also, add and subtract also you can do. That's not an issue. Both things are equal, same thing. Okay. So the answer is here is no, we actually cannot do. So let's see. So 2 into 2 x and then plus 4 plus 1 is equals to 0. So here what happened, this whole term, this x square plus 2 into 2x plus 2 square is equals to minus 1, right? So that means this is same as x plus 2 the whole square is equals to minus 1. But here we cannot take square root because minus 1 is there. So that means here the answer will be no, that we cannot find the roots of this particular quadratic equation by completing the square method, right? So that means this completing the square method is applicable over very limited number of expressions or limited number of quadratic equations. Okay. So here also we can do a little modification. So suppose in place of 4, if I have, in place of 5, if I have taken 3, then I think it can be solved by quadratic equation, completing the square method. Okay. So suppose in place of 5, I have 3 here. Okay. So then again add and subtract 1. Right. So 4x is there plus 3 plus 1 minus 1 will do is equals to 0. Right. Why we are doing? So that we will get 2 square. Right. So it's simply x square plus 4x plus 4 is equals to 1. Now I can say that, okay, see, it's nothing but x plus 2 the whole square, which is equal to 1. So that means x plus 2 will be equal to 1 or x plus 2 will be equal to minus 1. Right? Because whenever you take square root, you have to take plus minus both sides. Okay. So here this is same as x plus 2 is equals to plus minus under the root of 1. Okay, but under the root of 1 is 1 only. So that's why we have x plus 2 is equals to 1 and x plus 2 is equals to minus 1. So from this one, I can say that x is equals to 1 minus 2 and here x is equals to minus 1 minus 2. So that means x is equals to minus 1 and x is equals to minus 3. So now this particular equation can be solved by using completing the square method. Okay, so this is the completing the square method. Okay, so these are the two basic standard methods we will use to find out the roots of a quadratic equation plus the formula. We have explicit formula minus b plus minus under the root of b square minus 4ac by 2a. Okay, so these are all this is the almost all the information about any quadratic expression. Okay, is that clear? Any doubt so far?
No.
No, right? It's basic standard stuff. So that's all we have in our week 3 content. So it's all about quadratic equation and quadratic forms. So you can find plenty of questions in your activity practice GS. Okay. So now let's open up to the doubts. If you guys have any doubts, you can raise your hands and we can discuss your doubt. Okay.
This factorization method.
Yeah.
So see, all the numbers look very convenient on in these tests and all the
Mhm.
exams and everything because it's been designed for people to probably complete it within a certain amount of time, right?
Yeah, correct.
So in reality, do you actually find such numbers, or they're going to be really complex? Complex not in terms of root of -1, but I mean,
No. In reality, also, if someone wants you to solve a question by using factorization method, they will give such type of numbers only. Convenient number which can be guessed easily. Okay. So there won't be any large number whose sum and product we are not able to find. There will be only small numbers like 7 to at max they can go up to 12 two digit. For example, 11 and 2, 11 and 9, something like that. But it will be guessable because we know we already have an explicit formula. So if someone won't able to do by prime factorization, they will do by the formula. So they will always give you the small numbers only. Those numbers which you can easily guess.
but in real life, I guess there may
Yeah,
not be many.
obviously, in real life, we won't use the factorization method, obviously, because there could be data could be very huge, the coefficient could be very huge, so it's very difficult to find sum and product of such numbers, right?
Yeah, all right, that's what I had a feeling.
Right. And also, we have in real life we have plenty of calculators, right? So those calculators will do our job. So it's just theoretical knowledge we need that okay, this is also possible type of thing.
Sure, ma'am.
Any other doubt?
Are we also allowed to ask questions from week 2?
Yeah, you can ask.
Uh, can I? I'll post something on the chat box then.
Yeah, that will be better.
Hello, ma'am.
Yes.
Ma'am, just a doubt here is it, where do we use in data science the mathematical lectures which we are covering, this quadratic equation? Where do we
Hmm.
find it? Means how, like set theory, we use it in computational thinking, we use it
Yeah,
somewhere else.
so explicitly, I actually don't know. In ML course, you may learn some of the formulas which ultimately converted into some quadratic equations. Right. So, for example, in physics also, these type of things happen. You have some concept, and on that concept, you have some relation or some quantities, and ultimately it converted into some mathematical expression. Right, for example, that pendulum equation is there, some heat transfer equation. So such type of thing in data science also happens. Some probability equations are there, and they ultimately reduces to some quadratic functions or polynomials or those type of things. So that's why it's good to have knowledge of these things. It's a
Uh,
general. Yeah.
Understood. So we will not be doing any plotting.
Sorry, what?
We will not be doing any plotting like graphical art or anything, right?
No. I don't think we will do.
Means in the coming courses or where you will be learning the machine learning or any other
In
programming.
that thing, I think they will teach you some plotting things. So, for example, in programming, they will teach you how to plot functions, how to get a graph, and all those things. So there you can see the plotting type of thing. But there, the functions will be obviously complex. So because we are using computers, so they will give you the how to get a plot of any particular function type of thing. Maybe.
Okay, ma'am.
Yeah, actually, I'm not familiar for those courses. I know only about maths. So okay, so what's your doubt in this question, Dilip?
So in this question, it says that just a second, I'll just try to read it. It says R is a function because it has only one output for one input.
R is a function because it only has one output for one input. Yes.
Yeah, in the accepted answers, right? But what I had ticked on was R cannot be a function because it's a finite set.
No. Why it can't be a function? Okay, they haven't specified the domain. That's why you are saying.
Yeah, no, not just that. See, the domain is limited, right? It's finite. There's only five elements in the domain.
Yeah, it doesn't. That doesn't. I mean, that doesn't harm the property of function, right? So, what is a function? Function is any map from A to B, no matter what A is. It could be finite. It could be infinite. It could be anything. In such a way that for every A.
Okay. So, which means the domain
Yeah.
does not need to be infinite.
Infinite. Yeah.
It
For
can
example,
be fine.
if I say that f is a function from these three numbers a, b, c to 1 to 3, like this a is going to 1, b is going to 3, c is going to 2. This map is also a function.
Okay. All right, ma'am. I get it. And
Okay.
also, it's the third one which I had ticked on, right? Which is
Mhm.
R is a function because it's bijective on x and y. Because for all values of y, there is one x, and all values of x, there is one y.
Yeah, right.
Isn't it bijective?
What's that option? Third one?
Third one, as in what I had ticked, which is the second last.
If R is a function, then it is a bijective on x cross y, where x is a set of all values on the x-axis and y is a set of all values on y-axis.
Yeah, I mean, I thought that was right, but apparently it is not. So I just wanted to know, why is it wrong?
X is a set of all values and y is a set of. Okay, let me read the whole. Okay, so R is this thing. All values on x-axis and y is the set of all values on y-axis. So these are not repeating, obviously, for -2, 1.
Because see, all values of x have a corresponding y. There's no
Yeah,
x that
correct.
has been left out. And it's a 1-to-1.
Right.
And from
The
the
function on
y
x.
side, it's on 2. So isn't it bijective?
So this statement is actually very confusing. So here it says function on x cross y. So that means the elements are from x cross y. But
Could it be that here the domain also includes -3 and +3, but they don't have corresponding values of y?
maybe that's the case, but they should have specified that thing, right? So it's actually a confusing statement.
Yeah,
I
so
mean, it's not clear here
yeah,
that
yeah.
which values we have to take. Yeah, it is not clear there. Is this from graded assignment?
Yes, not graded, ungraded.
Okay.
I
So
didn't know if I was allowed to show graded here because a lot of people wouldn't.
yeah, correct. But since now the deadline is passed, so you can show. It's not
How
an
is the
issue.
deadline passed? Deadline is in June.
Oh, okay. Sorry. I forgot that this term is running like that. Now we have deadline in far away, right?
Okay.
Mhm. I forgot. Usually, what happens when we are teaching week 3, the week 1 deadlines are already over.
Oh, okay.
People get asked out. This time is not. Yeah, this is not actually the correct statement. They should have mentioned explicitly, first of all, this function on x cross y, this they should not write like this. It should be function from x to y or something like this should be there. And
Okay,
all
okay,
values of x and y, this is also they need to specify.
okay, okay,
It's not your fault that you have taken.
okay.
Okay. Can you tell me which activity or practice this question is? I'll try to correct it. Question number 5 is written. Hello?
Sorry, ma'am, I was on mute. I'll just go back to the course.
Yeah.
Just
Okay,
find
okay,
out
fine.
which the thing is. I'll send you the screenshot.
Yeah, fine. Okay. Any other doubt from anyone? Because week 3 is very basic thing, quadratic function you guys already know. But the questions may seem untrivial to you because they are written in some fancy ways or something like that. But the only informations you need is all about all are these things. What is a quadratic function? How to find a vertex? How to find the axis? And all those things. Okay. If there are any other doubt, you can post in the chat box and let me know.
Ma'am, I've just posted. That's the one where that question was.
Okay. Practice assignment, na?
Yeah.
I'll try to correct it.
Sure.
Okay. Any other doubt from anyone? Any conceptual thing you think you won't understand, you haven't understand, or is there any doubt? You can ask.
Ma'am, can we have a revision on the functions once again?
Yeah, sure. So see, what is a function? Okay. So function is actually a map or a correspondence or a rule, you can say, from a set to another set, right? From a set A to another set B, right? So any map or correspondence from a set A to another set B which possess two properties. So two properties are, so first property is this every word, that every element of A should get mapped to somewhere in B. Okay, so this is the first word you need to check for a function, that every element of A should have an image in B. Okay, and that image should be unique. So that means for every A belongs to A, the second word is this unique word. So for every A in A, there should exist a unique B in B such a way that this particular map F will take A as a input and give us B as an output. Right? So that means for every element of A, every element of A, first of all, every element of A should get mapped to somewhere. Right? And that somewhere should be a unique thing. For example, if you tell this corresponding to another people, they should be clearly understandable that if you give them an input, they will tell you the output by looking at the function. Okay, so that type of map or rules or correspondence or relation also are known to be function. Okay, so a map correspondence rule from a set A to another set B is said to be a function if every element of A, for every element of A, there is a unique element in B such a way that F is taking A as an input and giving us B as an output. Okay, now there is no restriction on set A and B. Set A and B could be anything. It could be name of people, it could be name of cities, name of countries, and it could be numbers, anything you can take. Okay, so these sets could be anything. So now let's start with some basic examples. For example, if I take set A to be sorry. Okay. So if I take set A to be these three elements A, B, and C, and if I say set B is nothing but 1, 2, 3, 4. Okay. And I will guide you that F is a map which takes A to 1, right? Which takes B to 2, and which takes C to 2. Okay. Now, can you guys see, is this a function?
No,
Why it's not a function?
because it should have a unique value.
No, unique means that B cannot be mapped to two different things. This is not a function, but this is a function. See, for B, there is a unique 2. For C, there is a unique 2. So one input should not map to two different outputs. That is not the uniqueness. Uniqueness, this thing. That okay, B is mapping to one thing, A is mapped to one thing, C is mapped to one thing. So that means, yes, this is a function. Is that clear? So unique
Okay.
refers that B cannot be mapped to two different outputs. This is not the meaning. This is violating the word uniqueness. Okay, unique means B should map to one thing, A should map to one thing, and C should map to one thing. That for a unique input, you have a unique output. Right? It is possible that an output can have more than one input, but for an input, you should need a unique output. Is that clear?
Yes,
So
ma'am.
the answer is yes, this is a function. Okay, now let's consider another example. So suppose I'll say that A is going to 1, B is going to 2. Now, is this a function?
Yes.
See, for function, we need to understand two words. One is every and another one is unique. Yeah, please give me 1 second. Hello? Yeah, sorry for that. So, what I was saying that for a function, you need to check two words. One is the every and another one is the unique. Every means every element of the domain should get mapped to somewhere. So here in this example, you can observe that the C does not have an output, right? So here the every word is not there, right? So that means it's not a function. Is that clear?
That means A, B, C, all of them should have to be mapped.
Yes, correct. Because they are the domain set or the inputs. They should be mapped to somewhere, and that somewhere should be unique. For example, A cannot get mapped to 1 and 3 both. Then this is not a function because it's violating the word unique. Okay, so let's consider one more example. So suppose F is a map from ABC 1, 2, 3, 4. Like A is going to 1, A is also going to 2, B is going to 3, and C is not mapping anywhere. Okay, now is this a function?
No.
No, right? Because it's violating both things. One is every because C does not have an image, not have an output or image. And another thing is for one input A, I'm getting two different outputs, which is not the property of function. Okay, so this is the definition of function. We say such type of maps to be a function. If one thing is every element of the domain should get mapped to somewhere, and that somewhere should be unique. That means for an input, we cannot have two distinct outputs. Okay, so this type of maps are known to be the functions. Okay, so now there is for it there are several ways to express a function. Okay, so this is the another thing that for expressing functions, We have different ways, right? So one way is this arrow diagram that you can, if you have a finite set, then you can just point it out or explicitly mention for an input what is the output. Then you can express that function. Another one is by giving expression. By giving expression means you will take x as an input, and you will tell what is the value of y given by some expression of x. For example, if I say that y is equals to 2x is a function, this is a function. It's a function from real number, set of real number to real number. So that means no matter whatever real value you will get, output will be 2 into that real value. So that means this is a function f from real number to real number, which is given by this particular expression y is equals to 2x. So this is another way of representing a function. Right? One is the arrow diagram. You can explicitly mention that for input, what is the output. Another one is giving by giving some expression for a function. For example, y is equals to 2x, or someone also write it as f of x is equals to 2x, which means that if you take x as an input, you will return that function will give you 2x as an output. Okay. Another example you can consider f of x is equals to 3x plus 2 by x plus 1. Right. Now this will be again a function from we have to restrict the real number, because we know that if you take x is equals to -1, this denominator will become 0, and divisibility by 0 is not well defined thing. So we'll say that this is a function from real number -1, sorry, minus 1 to real number. Okay, so this is another way to representing a function. Now the next thing to represent a function is via the graph. Via the graph means what you will do, you will collect all these points, x comma f of x. You will collect all these points and plot all these points over the graph. Then whatever figure you will get, that figure will represent the graph of a function. Right? So ultimately, graph of a function is nothing but a set over R2 plane with all these points. That is x comma f of x. Right? So that means you have to plot these functions. For example, if you have the function f of x is equals to 2x, then you have to plot all the function x comma 2x. Right? So you can say that, okay, I'll plot, so this is the value is 1. So for one input, I'll get 2 as an output. So 1 comma 2 is there. If I say 2, then 2 comma 4 is there, right? So you'll plot all those points. So if you plot all those points, ultimately you will get a figure, and that figure is known to the graph. Right? So these are the several ways to represent any function. Okay, so I'll recall again. So what is a function? A function is a map from a set to another set with two basic properties. One property is every element of the domain should get mapped to somewhere, and that somewhere should be unique. So that means for every element, there should exist a unique B in B. Such a way, f will take A as input and give us B as an output. Now there are several ways to represent a function. You can represent by arrows, you can represent explicitly stating the outputs for every input, or you can also give an expression to a function. For example, y is equals to 2x, or f of x is equals to 2x, or f of x is equals to x square, and all those things. Another way to represent a function is by the graph. So if you collect all these points, x comma f of x type of points, then these points, whatever the figure these points represents, is known to be the graph of a function. Okay. Now there is one more thing which is also known as vertical line test. For example, if you have a graph of, if you have any type of graph, and if someone asks you that this particular graph represents a function or not, then you can use vertical line test. So those things are there. Okay, is that clear? What is a function? Any doubt on function now?
Yes, ma'am. Yeah, ma'am.
Fine. So any other things you want to discuss?
Ma'am,
Hello.
can we have?
Yes, Sajid.
Ma'am, I have a doubt that the derivations that are taught in the quadratic equations are they important for their exams? Are they
Yeah, you will find some questions on quadratic equations. So
no, like
yes,
the derivation about the
sorry.
I was asking the derivations about the formula which are given there are the derivations important.
No derivation will be asked in example. You just have to remember the formula. On the formula based questions will be there only.
Oh.
Yeah. You don't have to remember that derivation, the proof, how we'll get the roots and all those things.
Yeah, just imply the formula and the questions will become.
Correct. Those derivation are just for your understanding that how these things come up. So you should just go and understand them, and the formula will be more than enough.
Yeah.
Okay. Any other thing?
Can we revise on reflexive and transitive? Let's just
Uh,
brief one.
okay. So what's your doubt in reflexivity and transitivity? See, until and unless you will do some example, these things won't be clear. So what do you think? What is a reflexive relation means? Because see,
Basically,
definition is just of one line. So any relation R on the set A, so that means it's a subset of A cross A. Or any relation on the set A is said to be reflexive if for all A belongs to A, these type of pair, A comma A type of pair are there in R. Okay, so ultimately, a relation is said to be reflexive if in that relation you will be able to find such kind of pair for all A, not for one A, not for one single A. Whatever elements are there in the set A, for all those elements, if such type of reflexive pairs are there, then that relation is going to be reflexive. Correct? Is that okay?
can you give an example, like any real life example?
Yeah. So, for example, you can say, let's suppose A is a set of numbers, 1, 2, 3, 4, 6 items. And I'll give you a relation R to be 1, comma 1, 1, comma 2, 3, comma 3, 4, comma 5, 6, comma 6, comma 2. Okay. So is this a reflexive relation? See, you just need to check the statement that for all A belongs to A, comma A should be there, that's all. If there are other pairs, that won't harm the reflexivity of a relation. Now, what do you think? Is this a reflexive relation?
We have 1 comma 1, 1 comma 2, 3 comma 3.
Yeah, we have 1, comma 1. We don't have 2, comma 2, right?
We don't have 2 comma 2.
Right. So that means for 2, the statement is false. So that means it's not a reflexive relation. If for if for one element only, the reflexive pair, that means 2 comma 2 is not there, or 3 comma 3 is not there, or for any one pair of single pair, the reflexive pair is not there, then you will say that it's not a reflexive relation. Okay, so that means for reflexivity, what you need to check is for all A belongs to A comma A type of pair should be there. Right. For example, in this example, 2 comma 2 is not there, so that means it's not a reflexive relation. Is that okay?
Okay.
Okay, so suppose I'll give you one more example. Now, is this a reflexive relation?
Yes, but not all limits are covered here.
Yeah, so how it would be reflexive? See, reflexive means for all.
Yes, so
Until
it
and unless
is
you
not
will get
reflexive.
for all a reflexive pair, it's not a reflexive relation.
So this is not reflexive.
Yeah, it is not reflexive because 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there, but 4 comma 4 is not there, right? 4
Yes.
comma 4 is not there, 5 comma 5 is also not there. So these two pairs are missing. So that means it's not a reflexive relation. Is that clear?
Yes.
Okay, so now I'll ask you one final question. So suppose R is a relation on the set of integers such a way that you will collect x comma y such that x and y both are integers, and the relation between x comma y is this y is equals to x plus 2. Okay, now is this reflexive? It's a little tough, whatever we have learned so far, but ultimately you have to think that if it's a relation on z cross z, what are the pairs I need to say that this is a reflexive relation? Okay, so can you say is this a reflexive relation or not?
So if we substitute numbers like integers, so integers will have negative also. So,
Yeah.
mm,
Uh,
so if I take suppose x, I'll take it as 1 and y I take as, can I take y minus 1?
no, see, relation between x and y is dependent on x. So if you fix x as
Yes.
1, your y
So
should
y
be 1
will be
plus 2.
3. Yes.
Yeah, y should be 3.
But no, but I cannot get it. So it will be 1 comma 3. It will become.
Correct. So that means
So
ultimately you won't have any reflexive pair here. You won't have 1
yes.
comma 1, you won't have 2 comma 2, 3 comma 3, right?
Yes.
So that means it's not a reflexive.
Okay. Understood.
Okay. So that's how you have to check for reflexivity. That you have to check if, okay, it's a relation on Z. So then I need all pairs. All pairs means minus 1 comma minus 1, minus 2 comma minus 2, 0 comma 0. All reflexive pair I need in this relation to say it's a reflexive relation. Okay. But here, since the restriction is y is equals to x plus 2, we cannot have these type of pairs, right? So that's why it's not a reflexive relation. Okay, so I'll ask you one more question. So suppose R is a relation such a way x comma y is there such that x and y are integers, or yeah, let's take integers. X comma y belongs to integer. Okay, now it's clear. So is this a reflexive relation?
Yes.
Just rethink again what I said for reflexivity. What type of pair you need? Here x is
No. No.
relate.
If y is equal to x, then it would have been. But
Correct.
it is
If
minus
y
x.
is equals to x, but since minus x is there, it's not a reflexive relation.
Understood.
Okay. So this is the reflexivity. Now the second thing is symmetricity. Okay. So symmetric relation. So for symmetricity, what you need to check? You need to check this statement. It says that if a comma b pair is there, then you should able to find b comma a pair. Okay. So that means if a comma b is in that particular relation, then if you are able to find b comma a pair also, then you can say that then R is symmetric. Okay. So that means you need to check that symmetric pairs are there or not. If a comma b is there, then b comma a should be there. If you want to say that is a symmetric relation. Okay. So let's take one example. So suppose I'll give you R is a relation like this: 1 comma 1, 1 comma 2, 2 comma 3, 3 comma 4, and 2 comma 2. Okay. Now, is this symmetric? Is this relation symmetric?
No.
No, right? Because see, for 1 comma 1, the symmetric pair is there because 1 comma 1 is there, then its symmetric pair will again become 1 comma 1. So this pair is not an issue for us, right? So it's a green tick that okay, this is fine, this is fine. But for this pair 1 comma 2, if 1 comma 2 is there, if I want to say that this is a symmetric relation, I need 2 comma 1 pair should be there, right? But we can easily check that 2 comma 1 is not there, right? So that means for this pair, we are getting that we are not getting any symmetric pair, right? So 1 comma 2 is there, but 2 comma 1 is there, 1 is not there. So that's why it's not a it's not a symmetric relation. So the answer is no. Okay, so symmetricity is easy. Is that okay? So let's say one more example. So again, I'll ask the same relation. Suppose R is the relation x comma y belongs to real number. Sorry, x comma y, such that x and y both are integers, and the relation between x and y is equals to x plus 2. Now, is this symmetric relation?
No.
No, correct. Because see, if you can check by substituting any integer. If you substitute x is equals to 1, you will get y is equals to 3. So that means 1 comma 3 pair is there, but 3 comma 1 won't be there. Because if the value of x is 3, then the value of y should be 3 plus 2, which is 5. Right? So 1 cannot be there. So that means this is not there. So that's why it's not a symmetric relation. Right? So symmetricity is kind of easy to check. We just have to check if a comma b is there, then b comma a should be there. That's all. Okay. So now the third thing is transitivity. So in transitivity, you have to check that if a comma b and b comma c is there, if you find such as a transitive pair, then okay. So first of all, if condition should be there. If these type of pairs are not there, you don't have to check anything. So vacuously you will say that okay, since there is nothing to claim that it's not a transitive relation, it's automatically become transitive. So I'll take that example too. So if you are finding a comma b and b comma c type of pair in your relation, so here observe the position of b. Okay, a is related to b, that is a comma b is there and b comma c is there. Then you have to check a comma c should be there. So if this statement is true, we can say that if this is true, then R is transitive. Okay, so let's take one example. So suppose R is a relation like 1 comma 1, 1 comma 2, and then 2 comma 2, and then 2 comma 3, and then 1 comma 3. Okay, so suppose this is a relation R. Now is this transitive?
Uh, 1, 2 is there. So can we tell 1, 2 is there? So when
Yeah, so if you are, see 1 comma 1 and 1 comma 2 is there, so their transitive pair, so 1 comma 1 is there and 1 comma 2 is there, so their transitive pair will become 1 comma 2 only. So yes, it is there, so that's true. So for these two pair, we don't need to check. Let's check another pair. So 1 comma 2 is there and 2 comma 2 is also there, and the transitive pair will become again 1 comma 2, which is also there in relation. See, relation is a set, so that's why we don't repeat the symmetry. We don't rewrite the elements again and again. So if there is 1 comma 2, that will be more than sufficient. Okay. Now there are other pairs too we need to check. So 2 comma 2 is there and 2 comma 3 is there. So for there, the symmetric pair will become 2 comma 3 again. So it's also there. Okay. Now next is 1 comma 1 is there and 1 comma 3 is there. So symmetric pair will become 1 comma 3. So 1 comma 3 is not, yes, 1 comma 3 is also there. So this is also there. So that means yes, for every whatever transitive pair we are getting, all the resultant transitive pairs are there. Right? So that means yes, it is a transitive pair. That's how you have to check. You have to first find the pairs like a comma b and b comma c, and then you have to check a comma c. Yes, Sajid.
I was asking that what is the syllabus in the quiz one? How many weeks is coming?
From 1 to 4. 1 to 4.
1 to 4.
Yeah.
But the exam is in July. Our fourth week is going to end in this month.
Yeah, it's okay. That won't be an issue. So you will have a break of 3 weeks, right? In between due to paradox. So
But
after 4 weeks,
but in that gap, week 5 and week 6 content will be released or just it will be halted.
no, it won't release. So they will release
So we
only
can
up to
revise
week
our
3 or 4.
syllabus in that gap.
Sorry, what?
In that gap, we can do our revision.
Yeah, you can just go and revise, and also we will conduct some revision sessions too before a quiz. Okay, so you will get also the revision there.
Then after giving the quiz, then from week 5 it will be started.
Yes, correct. Because of the paradox, we have 3 week gap in this stuff.
So total there are 12 weeks in this course.
Yes, right. Total 12 weeks are there. But you will have a 3 week gap, so that's why the term will restart again in July. Sorry, June or June and something is there.
So, which are the 3 weeks when there is a break?
Yeah, so I forgot. It's after 31st of May, I guess. So the 3 weeks are this first, second, and third week of June are the off, and then we will continue our term. So they have mentioned this in your grading document, right? So there is grading document in your portal. You can just go and check. They have explicitly mentioned what are the release date of the weeks and all those things. Okay. Grading document is the name of document. In the dashboard, the course instruction is there, na? So there you can check.
The grading policy.
Yeah, grading policy, all those things. There they have mentioned these things. Okay, just
I
go
was
and
asking one thing, like our identity card that when it is given.
ID card.
ID card. Yeah.
Those things I don't know. They may have given at the time of quiz one. So before quiz one, they will allot you the admit card and all those things. Okay. Yeah. So symmetricity, sorry, transitivity is like this. You first of all you need to first check the transitive pair. Are there any transitive pair? And if there are transitive pair, what will be the resultant pair? So if the resultant pair is also there, you will see that it's a transitive relation. I'll take one more example. So suppose R is a relation like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So suppose this is a relation R. Now can you say is this transitive? Is this relation transitive?
No, we don't have
Yeah.
any expression
Yeah. So
also.
this is the catch here. So see, in this relation, you are not able to find this type of pair, A comma B and B comma C. Right? There are no such pair. Correct?
Yes, ma'am.
Is yeah. So what has happened here? The transitivity says if you are able to find such a pair, then you have to check something, right? But the since if condition is not there, so then vacuously we can say that okay, there is nothing which can prove us wrong. So that's why it's ultimately transitive. So we will say since there are no such pair, this relation R is transitive. Right. So it's something known as vacuously true in mathematics. So vacuously true means if there is nothing to prove us wrong, we will say that okay, since there is nothing to tell us that this thing is wrong, so that's why we ultimately say yes, it is true. So here also same thing happening. There is no transitive pair. We have to check a certain condition. So vacuously we will say there is nothing to claim us wrong or false. So that's why it's true. Okay, so for such type of relation also, you will say that R is transitive. Is that okay?
Ma'am, so if we are not checking any condition, it can be
Hmm.
anything, symmetric also, right?
No, but in symmetricity, we just need A comma B, right? So it says that if any pair A comma B is there, B comma A should be there. So here there are pairs, right? So 1 comma 2 is there. For 1 comma 2, the symmetric pair will become 2 comma 1, which is not there. So it's not symmetric.
No, no, no. You're saying that since we are not checking any condition, if the question
Hmm.
comes, is this symmetric if they ask?
Yeah.
So there is no, if condition is not there, no?
No, no,
So
no,
I
no.
can say,
For symmetricity, the condition is only one pair. See, in transitivity, we need two pairs, A comma B, and B comma C. But in symmetricity, if part contains only one pair, A comma B, any pair A comma B. So that means for symmetricity, the if condition is any pair A comma B is there, you have to check B comma A is there or not. Right? In transitivity, we have specific condition for B that the place of B matters, right? A comma B should be there and B comma C should be there. So it's a strong condition other than having just a pair. Okay, are you getting my point?
no, ma'am, actually you said it vacuously, if there is no nothing is there, then we
Uh,
consider it as transitive.
correct.
So can I have the same vacuous condition for symmetric also?
Yeah, we have, but generally no. So there is identity relation. They will say. See, identity relation means 1 comma 1, 2 comma 2, 3 comma sorry, 2 comma 2, 3 comma 3, 4 comma 4. Suppose A is a set of 5 elements, 1, 2, 3, 4. So this is the relation, right? So here for all elements A comma B, all are since all are same, right? A is same to B, so that's why B comma A is also there. So here you can say that okay, symmetricity is kind of obvious, but in general there are nothing like transitivity. So you can say that okay, there is no vacuous condition for symmetricity. You have to check for each pair. That's your doubt, na? For the do we have a vacuous condition for symmetricity also?
Yeah, but also we can for reflexive also. So it's only the abacus is only for transitive.
Yeah, it is only vacuous in transitivity, not in reflexivity, not in symmetricity.
Okay.
Okay. Because their if condition is very small, a pair, right? A element in set A. So here only we have a specific thing, A comma B and B comma C. So that's why it's like a bigger condition we need to first consider and then check something. Right? It's known to be a transitive. Okay. Is that clear?
Yes, ma'am. Again, question is how do we apply these properties in data science?
Uh, Explicitly I can't say, but see, so one thing I know is graph theory, right? So in graph theory, we handle so many things by relations. So if you have a relation which is transitive and all those things, the graph will look very nice. So that means you have reachability type of things. So relations are actually the basics of graph theory. It's the basics of set theory, right? One more thing relation does is the partition. So that means if you have a very large set and if you define a relation which is symmetric, reflexive, transitive, combining these three properties, then that relation very nicely partition the whole set, right? So suppose this is a set A, then this relation will give us a very nice partition of the set R, right? So these kind of things also relation does. So that's why relations are the basics of all stuff. Right. So explicitly, I don't know, but implicitly they are there. Okay. So graph
Okay.
theory is a very applicable field. So it's based on relations too. So relations are very useful in graph. So if you understand relation, it's helpful to understand the graph and their applications.
So we will be reading graph theory in future.
Yeah, you need graph theory in future because data science is based on graph theory too.
Understood. Okay.
Okay. Okay. Any other doubt from anyone? So see, this course will go very slow up to week 6. But after week 6, it will pick a tremendous amount of speed. So that means you just have 3 weeks, 7, 8, 9 to understand the very important concepts of limit, continuity, and differentiability. And integration too.
Could you just say that again, ma'am?
Yeah, so actually what happened, this particular course will go very slow from week 1 to 6. But after week 6, you just have 3 weeks to grab these concept of calculus. So if you have time, you can just go and watch the videos over YouTube to get in a pace, right? So meaning is these things are little difficult and there is very less time to cover these things, limit, continuity, differentiability, and integration.
Okay, so all the videos are still available online without
Yeah,
actually having to wait for IIT to
release it. Yeah,
release.
correct. Because there is a YouTube playlist of Maths 1. So you can just go and search Maths 1, DS, IIT, and BS. You will get the whole playlist of one playlist is there by the professor. That professor has recorded all the lectures, and another playlist is there of Hindi videos, right? Maths 1 Hindi videos are there. So you can, if you have time, then I'll suggest just go and at least cover the theory of these weeks, right? So that you just when the week release you just need to practice and all those things, the concept is already clear. So that thing you can do if you have time then only,
Okay, ma'am.
because this usually a student will complain, see the course is very slow up to week 6, now what happens, suddenly we have so many things to do. But that's the thing happen in this course. 1 to 6 is very basic thing. 7 to 8 7 8 9 is pure calculus, limit, continuity, differentiability, and integration. And then we have 10 to 11, which is the whole graph theory part. So this is graph theory. So in graph theory also we have so many concepts, so many topics, and 10 and 11 are the weeks where we have more number of lectures with more time interval. So there are half an hour lectures, more than half an hour lectures in these 2 weeks. And there are again 10 lectures of each week. So here also you won't get time to grab everything. But it's okay. if you have time, you can just go and see those videos. That will be helpful.
Okay, ma'am.
Okay. Is there anything else we need to discuss? Any other doubt?
Ma'am, you said week 6, 7, 8, no, 7, 8, 9, no? So those are not dependent upon anything. They are directly basics of calculus, right? So
Yeah, basic limit continuity differential.
understood. Okay.
Okay. Okay, so if you guys have anything, we can discuss. Otherwise, we can wind up our session here today. Any other doubt?
Ma'am, when is your next lecture, ma'am?
Yeah, so we have planned next lecture on Saturday, but we don't have anything to do on Saturday, so we'll see. It will be on Saturday or after the break of 3 weeks.
Okay. Okay, ma'am. So we prepare by Saturday. I'll try
Yeah.
to watch the 7, 8, 9 lecture.
Hmm.
It is okay, ma'am, if we ask those doubts?
Yeah, it's okay. You can ask doubts from any of the content. If you have gone through something and you find that is difficult, we can discuss here. That's all for live sessions, right?
Okay, ma'am. Right, understood.
Okay. Okay, then see you guys. If you don't have any doubt, we can wind up our session here. Thank you for joining. I'll be here for next 5 to 10 minutes. If you have doubts, we can discuss.
Thank you, ma'am.
Thank you, ma'am. Okay.
Okay. Thank you. Good night. Bye.
Good night.